right, everyone, we have story problems today, just like we had on Friday. So remember that you want to think to yourself, can I draw something? It can be a tape diagram, it can be an area model. So what can you draw? And then you want to calculate to solve, write your statement, and then at the very end, you want to always check your answer. So what we have here is problem number 1. The length of a flower bed is 4 times as long as its width. If the width is 3/8 meter, then what is the area? So remember, area is length times width. So we know what the width is, right? We know our width is 3/8. The length is 4 times the width. The length is 4 times 3/8. Okay, so now we have, our area is 4 times 3/8, which when you multiply across, you get 12/8 times 3/8. Okay, 12/8 is the same. 8 goes into 12. Or, nope, not 8 goes into 12. What we're going to do is we're going to take 4. The number 4 goes into 8 2 times. It goes into 12 3 times. So now we have 3 halves times 3/8. What we did was we made 12/8 smaller. Well, the numbers smaller. And when we multiply, we get 9/16 for our area. 9/16. What is our label? Meters squared. 9/16 meters squared. So remember today you can draw an area model, or you can just do your math. So this was the math, or you can draw your area model. So we know our width is 3/8. And we know that our length is 12/8 or 3 halves. 3 halves is the same as 1 1/2. Okay, 1 plus 1/2. So we get 3/8 times 1, which is 3/8. And then we get 3/8 times 1/2, which is 3/16. And 3/8 plus 3/16 and we can't do this because why can't we add these together, everybody? Yeah, because the denominators aren't the same. So we have to turn 3/8 into 16ths. 8 times 2 is 16. 3 times 2 is 6. So we get 6/16 plus 3/16, which gives us 9/16 as our area. We are not done because we didn't write our statement. So what is your statement, everybody? What is the area of the flower bed? The flower bed area is 9/16 meter squared. Good job. All right, moving on. This is a problem set number 1. If you want to take a look at it, that's exactly what we did. Now, problem number 2. Problem number 2. Mrs. Johnson grows herbs in square pots. Square plots. Her basil plot measures 5/8 yard on each side. Find the total. So we have A, B, and C here. We have find the total area of just the basil plot. So let's do that first. So 5/8 on each side. So here is A. So this is number 2, A. Find the total area. So the area is 5/8 times 5/8. Okay, 5/8 times 5/8 equals 25 over 64 yards squared. You just multiply straight across. So we found A. Now we have to do B. So B says Mrs. Johnson puts a fence around the basil. If the fence is 2 feet from the edge of the garden on each side, what is the perimeter of the fence in feet? So what she's talking about is she has her basil, and then she puts a fence 2 feet around the basil. So it's asking that if the fence is 2 feet from the edge of the garden, so this area is 2 feet. 2 feet on all sides. What is the perimeter of the fence? And remember, the word perimeter is all the way around, just the length of the sides around. Okay? So, what do we have to do? How do we find this? Well, we know the area. We know that these sides are 5/8. Each side is 5/8, right? So each of our sides is 5/8. So 5/8 of a yard. 5/8 of a yard equals 5/8 times 1 yard. We need to know what is the length of each side, right? What is the length of each side? So we have to take that 5/8 again, it's 2 feet on this side and 2 feet on this side. So what do we do next? That's 4 feet total, right? So we have 2 feet on this side, 2 feet on this side, which is 4 feet. But what about this section? what about this 5/8 section? So we know this part is 5/8. So we have 2 feet plus 2 feet, which is 4 feet plus 5/8. What can we do? Okay, so we did A. And B. Let's see. A. Oh, they skipped to C. Okay. So now we're going to draw so we know that we have 2 feet and 2 feet and then 5/8. So that is the length of one side. So the length of one side is 2 feet from the edge of the garden on each side. I'm going to zoom in. So this area is 5/8 of a yard. Remember, now you see that we have yards and feet. So we have to know, well, what is 5/8 of 1 yard? How many feet is that, right? So 5/8 of a yard is 5/8 times 1 yard, right? What about 1 yard is how many feet? 5/8 of 3 feet. 5/8 of 3 feet is 15/8 of a foot, which 8 goes into 15 one time, 7/8 of a foot. So now we know that this middle part, 5/8 of a yard, is actually 1 7/8 of a foot. 1 7/8 of a foot. Okay. So now we're going to add 4 feet because of I'm going to do it in orange, 2 feet plus 2 feet plus now we have 1 7/8 because this 5/8 now is 1 7/8 feet. It used to be yards, but we had to convert it to feet. Okay, so we're going to go all the way down here. Just wanted to show you what I was doing. So 1 7 7/8 plus 4 feet gives us 5 7/8 feet. That's for one side. The perimeter is all the way around, so how many sides do we have? 4. So we're going to take this 5 7/8 and we're going to multiply it by 4. 5 times 4 is 20. 7/8 times 4 is 28/8. 8 goes into 28. 8 times 2 is 16. No, 3 times. 24. So 3, 24, and 1/2 or 4/8. So 1/2. So 20 plus 3 and 1/2 is 23 and 1/2 feet. So the perimeter is 23 and 1/2 feet. And you write your statement. The perimeter of the fence is 23 and 1/2 feet. That is a lot of work that we had to do for just one problem, you guys. You had to really think about, well, this is 5/8 of a yard, but we can't just add 2 feet plus 2 feet plus 5/8 of a yard. We have to know how many feet 5/8 of a yard is. So one side there was 5 and 7/8, and then we multiplied it by all 4 sides and got 23 and 1/2 feet. Very good. So this is C. I guess it actually did it for you. C said, what is the total area in square feet that the fence encloses? So each side is 5 and 7/8. So length times width. Just wants to know what the area is. So 5 and 7/8 times 5 and 7/8. And over to the side, it's doing the area model for you. So 5 times 5 is 25. 5 times 7/8 is 35/8, which is 4 and 3/8. 5 times 7/8 is 4 and 3/8. And then 7/8 times 7/8 is 49/64. So when you add all of those together, you get 34 and 33/64 feet squared is the area. So a tiny, tiny, tiny bit more than 34.5 feet. All right, number 3. You guys are working hard this morning. Number 3. Janet bought 5 yards of fabric, 2 1/4 feet wide, to make curtains. She used 1/3 of the fabric to make a long set of curtains and the rest to make 4 short sets. So find the area of the fabric she used. 5 yards of fabric, you guys. Look, here we have feet and yards. So we're going to have to convert that yards to feet, okay? Because we have 2 different measurements. So we're going to find the area. So 5 yards of fabric that's our length. That is our length. That goes this way, which is 5 yards times 3 feet gives us 15 feet. By 2 1/4. Okay, so 2 times 15, 30. And then 15 times 1/4 is 15/4, which is 3 3/4. And when you add those two together, you get 33 3/4 feet squared. So the area is 33 3/4 feet squared. Okay, that is for the entire set. Okay, but we don't necessarily need that entire set because it says she used 1/3 of the fabric to make a long set and the rest to make 4 short sets. So we have to know what 1/3 of 33 3/4 is. So this is the long set. So 33 and 3/4. And we want 1/3 of it, right? Remember, of means multiply. So we're going to do that distributive property. Okay, and we're going to do 33 times 1/3 plus 3/4 times 1/3. 33 times 1/3 is 33/3, which equals 11, because 3 goes into 33 11 times, plus 3/4 times 1/3 is 1/4, because it's 3/12, which gives you 1/4. So the area of the long curtain is 11 1/4 foot. Area of long equals 11 1/4 feet squared. Area is feet squared. B says find the area of the fabric she used for each of the short sets. So now we have to, this is the area of the long, and 33 3/4 is our total area. So the remainder of the fabric that she has left would be 33 3/4 minus 11 1/4. That's how much she's going to have left. Okay. And then if she makes 4 sets, we're going to have to multiply it by 1/4 to tell us what each set is, because that's like dividing by 4. Okay. So 33 3/4 minus 11/4 gives us 22 1/2. 33 minus 11 is 22. 3/4 minus 1/4 is 1/2. So we have 22 1/2. Now divided by 4 or times 1/4. Okay, this is going to tell us because we need 4 sets. So 1 out of the 4 sets is how long. So when we do this, remember you use that distributive property. We do 22 times 1/4 and then 1/2 times 1/4. So 22 times 1/4 plus 1/2 times 1/4. 22 times 1/4 is 22/4, which is 5 1/2. 4 goes into 22, 5 times. All right, and then we have 1/2 times 1/4. When you multiply straight across, you get 1/8. So 5 1/2 plus 1/8. We know 1/2 is 4/8, so plus 1 more 8 is 5/8, because remember you cannot add these together. So you have to take that 1/2 and you turn it into 8ths. So we have 5 4/8 plus 1/8, which gives us 5 5/8. So the area of the short curtains, this is each of the short curtains, is 5 5/8 feet squared. Wow, y'all. We are working our brains today. Okay, and that's what they did. All right, you have one more today. One more. Problem number 4. Some wire is used to make 3 rectangles, A, B, and C. Rectangle B's dimensions are 3/5 centimeters larger than rectangle A's dimensions, and rectangle C's dimensions are 3/5 centimeters larger than rectangle B's dimensions. Rectangle A is 2 centimeters by 3 1/5 centimeters. So we have rectangle A which we said was 2 by 3 and 1/5. It says rectangle B's dimensions are 3/5 larger than rectangle A's. 3/5 larger, so that means rectangle B, instead of 2, it's going to be 2 and 3/5. And instead of 3 and 1/5, you got to add 3/5 to that, which gives you 3 and 4/5. 3 and 4/5. So this is B. And then we have C. We have C, which said rectangle C's dimensions are 3/5 larger than B's dimensions. So you have to add 3/5 to each side. So 2 and 3/5 plus 3/5 gives us 2 and 6/5, which equals 3 and 1/5. And then adding 3/5 to 3 and 4/5 gives you 3 and 7/5, which gives you, which turns into 4 and 2/5. So now we know all of the dimensions. So now we have to find the area. Now we have to find the area, you guys. So 3 and 1/5 times 2. So here's A. We have 3 and 1/5 times 2. 3 times 2 is 6. And 2 times 1/5 is 2/5. So area, whoops, I'm going to zoom in. Okay, we have 3 times 2 plus 1/5 times 2. 3 times 2 is 6, plus 1/5 times 2 is 2/5. So 6 plus 2/5, which is 6 and 2/5. So the area of A is 6 and 2/5 centimeters squared. Okay, now I could have done that by drawing an area model or using my multiplication, just like I did. All right, so now we have B. So the area of B is 2 and 3/5 times 3 and 4/5. So you can do the math or you can do the area model. You have to multiply 4 different things, right? We have 3 times 2 plus 4/5 times 2. And then we have plus 3 times 3/5 plus 4/5 times 3/5. Lots of math there. 3 times 2 is 6. 4/5 times 2 is 1 and 3/5 plus 3 times 3/5 is 1 and 4/5 plus 4/5 times 3/5 is 12 25. Okay, 6 plus 1 is 7, plus 1 is 8. And then you can't, 3/5 plus 4/5 is 7/5. So 6 plus 1 plus 1 is 8. Okay, we just added the whole numbers. Now 3/5 plus 4/5 is 7/5, plus we still have 12 25ths. Okay, whoa. Okay, 7/5 is 1 and 2/5. So 8 plus 1 and 2/5 plus 12 over 25ths. 8 plus 1 is 9. So now I have 9, and I have 2/5 plus 12/5, or 12 25ths. So now we have to convert 2/5 into 25ths times 5 times 5, which gives us 22. 5 times 5 is 25. 2 times 5 is 10. So I have 10 25ths plus 12 25ths. 9 plus 10 and 12 is 22 25ths. 9 plus 22 25ths is 9 and 22 25ths. Wow, you guys. Wow, wow, wow. So that's just for B. So the area of B is 9 and 22 25ths. So the area of B is 9 and 22 25ths, and then we have the area of C. So the area of C, I'm actually going to make an area model. I have 4 and 2/5 and 3 and 1/5. 3 1/5. Okay, 3 times 4 is 12. 4 times 1/5 is 4/5. 2/5 times 3 is 1 and 4/5. Okay, because 2 times 3 is 6 over 5. And 2/5 times 1/5 is 2 25ths. And then you add all these up together. If you just add the top portion, we get 12 and 4/5 plus our bottom portion is 1 and 4/5 plus 2 25ths. So you have to change the 4/5 to 25ths times 5 times 5. Or maybe it's 1. 2/5 times 3 is 6/5. So this is just 1/5. I'm sorry. 1/5. Because 2/5 times 3, 2 times 3 is 6. We have 6/5, which gives us 1 and 1/5. So, my bad. So 1 and 1/5. And then 2 and 25. So 5 times 5 is 25. So we have 7. 1 and 7 25ths on the bottom. So what I did was I added these and then these. And then you add those two together and you get 4/5 plus 7 25ths. So now I have to convert 4/5 into 25ths, which times 5 is 20. 20 25ths plus 7 25ths gives us 27/25. So I have 13 and 27/25. 27/25 is 1 and 2/25. So 13 plus 1 is, so I have 14 and 2/25 centimeters squared. So that is the area of C. Wow. Wow, wow, wow. So that was just doing A, you guys. So we found the area of the 3. A is 6 and 2/5 centimeters squared, B is 9 and 22/25 centimeters squared, and C is 14 and 2/25 centimeters squared. And so now C or B says if a 40 centimeter coil of wire was used to form the rectangles, how much wire is left? So what you have to do is the perimeter. So the total area altogether, if you add up 6 and 2/5 plus 9 and 22/25 plus 14 and 2/25, you get a total of perimeter of 30. So 6 and 2/5. That's A. Plus, this is the area. 9 and 22/25 plus 14 and 2/25. 2/5 is 6 and 10/25. So now we can add everything together and we get 29 plus these two, and you get 29 and 34/25. 34/25 is the same as 1 and 9/25, so then we get 30 and 9/25 centimeters. Centimeters squared. That's the total area. Total area. So remember, a perimeter is all the way around. So the perimeter of the first square is, we have 2 inches. So if we go all the way back up to A, we have our sides. Okay, we have 3 and 1/5, and we have 2. So now what we're going to have to do, I'm going to show you what they did for C, and we'll talk about it here. So they just did numbers here. They did 1, 2, and 3. So 2 times 5 and 1/5 gave us 10 and 2/5. And then number 2 is 2 times 6 and 2/5, which gave us 12 and 4/5. And then the last one, number 3, 2 times 7 and 3/5 gave you 15 and 1/5. So the total perimeter is 38 and 2/5. Remember, perimeter is all the way around. All the way around. Just the edges. So 1 and 3/5 centimeters of wire left. Because then you take 40 centimeters and then minus it by that 38 and 2/5. A lot of math today, everyone. A lot of math. All right, so your debrief. Think about some of these questions. Okay, it talks about comparing problems for which the distributive property seems most efficient. It says sort problems from yesterday and today's lessons, so from 14 and 15, from simple to complex. What do the problems have in common? So you can think about that. And then you have your exit ticket today. Wheatgrass is grown in planters that are 3 1/2 inch by 1 3/4 inch. There is a 6 by 6 array of these planters. With no space in between them. What is the area covered by the planters? Okay, an array, this is the only thing I'm going to do to help you guys. Okay, we have a planter that is this big, right? Let's just say, if we have a 6 by 6 array, that means you have 6 going this way of the same planter and 6 going this way of the same planter, and then you have to fill these in. And it's asking what is the total area. Okay, that is my help for you today. I hope you have a fabulous day, everyone.